So let us examine say a football as it comes down an inclined plane. When does it start rolling? Okay, so as it comes down, you know, what is happening here? Let's find that out. Now, initially, what would you expect to happen? Obviously, there will be some sliding. It will slide down. Okay, so it will slide down and acquire some velocity. Now, but as soon as it slides down, it's also going to have a force of friction opposing the motion. So we will have a force of friction acting on it in this direction. Okay, it's going to try and reduce the velocity, but as it goes down, it's going to gain velocity. No doubt about that. But more than that, what it's going to do is going to create a torque in this direction. Okay, so the ball is going down with some velocity, and as it goes down, it also starts to rotate. So if we examine this point here, what is happening here? This, whatever this velocity is, at a certain instant, is going to act here also at all points of the ball. So it's going to act here also, right? Now, again, the torque here will generate some angular velocity omega. If this ball has a radius, say r, okay, then a time will come when the linear velocity at this point due to rotation, omega r, okay, will match the velocity v here. Because as it goes down, the torque here, the friction acting on it, say if the friction force is F, is going to create a torque here, and that will be F into R. Okay, and that is going to generate an angular acceleration here, I, as we know. So with time, omega should increase till a point comes when here at this point we will have a situation where omega r should be equal to the velocity v, this velocity v. This is a condition for pure rolling. Okay. Now what is that condition here? This point, if it has zero velocity, because the velocities are opposite and they are opposing each other, should have zero velocity. So this point apparently doesn't move. Well, that sounds fantastic, but what is happening here? This point is generating an instantaneous point of rest. Now that again sounds fantastic. What is it it's generating? If you can write it down. Right? But the ball is rolling down. So what is happening? At every instant, one point of rest is being replaced by the other. So we have a fantastic situation here where we have a point of rest, and this is actually generating an instantaneous axis of rotation about which, if this were a stuffed football with sand, all the particles would move along this instantaneous axis of rotation. Okay. So what kind of a friction is friction still acting? The point is not moving. Is the friction still acting? We have a new kind of friction. We call that rolling friction. Okay. We call
Yes,
that
sir.
rolling friction. Now this rolling friction is somewhat lesser than the usual kinetic and static friction. Also, you notice that because this point is a position of rest. So if somebody were to force you to saying that, give me a term I'm familiar with, I have, you were giving a new term, rolling friction. I only know static friction and kinetic friction. So out of that, if you were to choose, say, then would you classify this force of friction? If you were forced to choose between those two, you don't know something called rolling friction. It's a new term you just encountered. What we have here is the ball starts rolling down, sliding down, and the velocity here increases. Uh, but at the same time, the friction is creating an angular velocity because of the angular acceleration it generates, and slowly the omega is increasing to a point where it somewhat becomes closer and closer. At a particular instant, it matches the downward velocity. So at this point becomes a position of rest, instantaneous position of rest. And then in the next instant, a new point comes in, and so it rolls along. That is what it is, right? Now, I said that then this friction is still operating. Yes, friction is still operating possibly because it's going to maintain the torque, right? Now, so that friction would classify as something new. It's called rolling friction. But if I were to force you into saying that, you only know two types of frictional force. Yes, static, and kinetic friction. So somebody would force you to saying, I don't want to accept this rolling friction for now. If I were to choose static and kinetic friction, you are saying friction is there. Which one would you choose? This is a position of rest. That is the clue. What would you say?
So it's a static friction.
Very good. Because it's a position of rest, in that case, we would classify that as static friction. And it's fantastic to think as the ball is rolling down, this point is always at rest. A new point is replacing the old one. And if you can see, if I had to ask you another question, that what is the uh, work done by friction here? See, if there were a question, say during rolling, when it was rolling, we understand that the point is not moving, right? So what work is done by friction when it is rolling? Yes, we know what is work. Work is force into displacement of the point, right? Here the point is not displacing. So during rolling, friction seems to do no work. That's very important, right? You get that?
Yes, sir.
I'll repeat it all again, but did you get it? Get it till now?
Yes, sir, I did.
Okay, so coming back to that again.